All right, good morning, JFocus. How you doing? Good morning, Internet. Thanks for joining us today. And for those of you who want to check if you're in the right room right now, it's a talk about Kafka. I think it's quite popular on this conference. The previous talk was awesome. And today we're going to be talking a little bit unusual topic for developer conferences, how you can build something that runs without actual coding. How exciting is that? Exciting? Yeah, because the good developer, it's a lazy developer, right? So why write something if you can achieve the same without writing anything? And essentially, yeah, Apache Kafka, it's a streaming platform. We're going to be talking all things Kafka and all things around Kafka, how we can do things with Kafka, using Kafka, so far and so on. All right. There is a common misconception, I would say, or there's a common belief that Kafka, it's just another messaging system. And because the Kafka has certain patterns of messaging system, or like if it's quacks like a duck and moves like a duck, maybe it's a duck, right? Maybe it's a messaging system. And one of the use cases when the Kafka started back in the day in LinkedIn was actually using some of the message-driven pattern, where you have a producer and you have a consumer who can subscribe to the data. And it's still quite legitimate use case for many Kafka users. This is kind of your the way how the people enter the Kafka. I think, it's a messaging system. Let me try to replace my Rabbit or other MQ system. So we have certain messages that go in there into Kafka topic. Kafka has topics. And so this is why it's also very popularized the concept among messaging system. This stuff is going into Kafka, and you can build message-driven applications. But can we do better? Can we do something else with Kafka? Like why Kafka, and why it's something different from the other systems? Kafka is a streaming platform, so it has a stream processing capabilities in order to process these messages and do something new with it, so create some derived data. One of the use cases where the Kafka actually shines is use cases with data enrichment. So you have some master detailed data stored in some database, maybe it's a relational database, maybe it's something else. You have the stream of changes from this database coming into Kafka, or maybe it's just a load of this information that the reference tables will be available in Kafka. With new arrived order messages, we can enrich this information. Once we have order information with some dumb IDs, we can enrich this data based on our master data. We have some additional data about the customers. So what we can do with this data, we can just simply consume, and some application will do something with it, or we can build some of the analytical dashboards, and we can build this using tools that are available today and people use a lot, building this nice dashboard or some like a reporting systems and so far and so on. Interesting use case that is actually very common these days is to use Kafka to evolve your legacy process, where you have some existing like data warehouse or like database system where existing app writes the data, and the changes from this database will be transferred into Kafka topics, right? And for the next step, we can onboard new application that will be solely working in event-driven fashion. So you can bring more application that will use same data that was available only through this system. And after that, you can decommission your legacy system and keep going in your modern and event-driven architecture. So Kafka is event streaming platform. So what does it mean in order to understand this for data engineers, the software engineers? What does it mean? So Kafka supports not only the transfer in the PubSub fashion, but it also provides tools that allow you to do easy publishing of the messages, or maybe ingestion from existing sources, and stream processing tool was more important. The Kafka comes with a rich Java client that provides the producer and consumer API. So you can focus on writing apps that's simply writing some data and reading data. Kafka comes with fantastic tool called Kafka Connect. Kafka Connect is a runtime. There's a part of Apache Kafka that allows you to build connectors so you can connect different system external to ingest data, or you can offload this data to something that's appropriate for display. Like you can build a dashboard. This is what we'll be focusing today. We'll be using Kibana to display this data that comes from Kafka, from database, from relational database, through Kafka Connect connector, through Kafka, into Elasticsearch, and after that we will be displaying this in Kibana. Another use case how the Kafka can be used is to bring the data into the system for longer storage. You do something with this, you extracted this data from some old system, and you want to persist this for a very long time. So you can offload this into things like S3, HDFS, and some sort of data lake technology. And the cool thing about this, that the data stays inside the Kafka. So you can enable multiple use cases with the same data. Once data in Kafka, Kafka becomes your source of truth. So we're going to be looking to how we can produce derived data from data that we already have in Kafka topics today. So the Kafka Connect is really powerful runtime, and the power of this runtime is actually proven by many developers who develop a bunch of connectors, including some commercial vendors that develop connectors for their systems, plus some open source vendors. Two types of connectors exist. Source connectors that allow you to bring data from existing database, from existing sources into Kafka, and sink connectors that allow you to, after you're done with this data, you can offload this to some sort of system. And you can build data pipelines without coding, right? So you have a connector to bring data in and to bring data out. And in order to help people to, get this stuff going very easy, we at Confluent, we're building tools, we're building things that allow people and developers to focus on solving tasks rather than reinventing the wheel over time. Every time you think, oh, I need to bring the data from Oracle to Kafka, should I write an app? You should not. You should get the connector and start using connector, because do not reinvent yourself unless you get paid for writing connectors. So in this case, it's the totally legitimate use case. As I mentioned, we at Confluent, who are Confluent? Confluent is a company that was founded by initial committers and initial founders of Apache Kafka. And we build tools and different enablement materials that allows to run Kafka as a neural system of your organization, to bring data, to move the data around your organization. And this is one of the many things that we do in the Kafka Connect, Kafka Connect hub store, or like hub, or like app store for connectors. There's a tool that allows you just install connector into existing installation of Kafka. When you start building this streaming platform that will be tied and that will link multiple organizational applications in your organization, your company, you will start facing a situation where you need to have a data around your data, aka metadata. And this metadata will be describing like how your data looks like, how it data looked like on the very beginning, and how this data should look in the particular system. So for example, like if we're using a relational database, we have a table, we want to have this schema of the table. We don't want to lose information, for example, about dates, about certain types, and so far and so on. So there should be some universal language allows us to translate to things that we have in database, in relational database, to things that we have in, for example, in Elastic. So, and we think the Avro format and schema registry that supports this format is actually a good candidate to do that, to bring this gap. And we'll see some of the schema registry examples today. So essentially, Kafka don't care about your data. Kafka cares about bytes. So schema registry care about your data. Schema registry will hold information on the schema. It will also version it, so you can have backward and forward compatibility data. You can do checks in case of you want to check if your data that came from Kafka is compatible with schema that your application currently using. So it is quite powerful, and it's enabled a lot of data governance aspects inside the Kafka. So the way how we operate as developers, obviously developers want to see some code. Here's some code. Developers operate with Kafka Connect using the simple REST API. So once your connector jars, essentially in the class path of the Connect framework, you're using curl and start this connector. So what happens here, we're specifying what kind of connector we're using here. In this particular case, Elastic Sync Connector, meaning that we will be dumping data to Elastic. Because, again, Kafka don't know anything about your data. We need to tell what kind of data is there. So we're using serialization and deserialization aspects. So in this particular case, our key is a string, and our data is a JSON. And connection URL is where our Elasticsearch is located. So enough words. Let's start building something. Let me, actually, I already built, so I will show you something so you can after that grab and build something yours. So in this case, it is going to be something interesting. So the simplest use case that we're going to be exploring right now, that will include a couple things. Simple Kafka producer that will write data in Kafka topic. And I will have a connector that will listen changes from MySQL database. There is open source project called Debezium that allows you to listen bin log of MySQL and capture all the changes as they occur in database without constantly polling it through JDBC or some other mechanism. So database has this source of truth called transaction log. So remember this idea, because I will return to this when I want to build the final thought about the Kafka as a source of truth. So database uses the transactional log as a source of truth in order to generate this or materialize this into tables, views, and so far and so on. So let's see how it goes. So in my setup, so what do I have here? There is my Kafka. Is it big enough? Can you see it very well or not much? Have a look in on font. We see it good or not? Small, big, because I don't see because it's not translated like directly. Let me, just in case. So I'm not going to be running every other components going to each and every screen because there's multiple things. And being lazy developer, meaning that I need to automate all these things. So essentially, if you want to reproduce all these things, I have awesome things called Docker Compose, which is, how many of you guys using Docker or any type of containers? Awesome. So I think this is a great way to share some of the knowledge. So this is why my application already includes everything. It has a Kafka, it has a keeper, it has a schema registry. Everything is already set up. Everything is running inside containers. So what I need to do is just start building my app. And we at Confluent believe that we need to enable you with this tool so you can focus on building apps rather than building infrastructures and stuff. So we got you covered on this point. So all these Docker images for all components that you'll be showing available either from, no, it's basically everything is Docker Hub. I have this the KSQL Debezium. This Debezium, it's also a connector that runs inside Connect framework, and Debezium will listen my MySQL. So let me switch to screen number 2. So, and I will start my, where's my Kafka cat? So Kafka cat is the console tool that allows you to produce data and read data from Kafka topics and so far and so on. So in this case, Kafka cat, it's an application written in C++. It uses C++ library called librd-kafka that essentially foundation for many Kafka clients that out there. I'm running this in Docker because Docker is fun, it's cool. Now, if I will do something like, so hello gfocus, so I will produce this text bit into my Kafka topic, and let's see if I'm able to observe it into my Kibana dashboard. So what happens here? I have my Kafka running. I have my client that produces data into Kafka running. I produce it to topic. I have Elasticsearch connector running that listens the changes from this topic and produce this data into Kibana. So this is something I just produced. If you don't trust me, I can type something like, hi. I think it's hello. Let's use some emoji, I guess. It's interesting to see how Kafka is awesome. All right, so I'll use some fire. Say it again? Yep, you're right. I missed the bit because Jason is very picky. Let's do it again. I always love when the people get engaged and suggested me some typos that I'm doing. So this is why I'm doing these typos on purpose. So it goes to internet somewhere. Supposedly, it's supposed to show on the screen. Hopefully, maybe I broke something, but it's demo. It's fine, probably. Or maybe someone that doesn't understand Unicode. So which is very interesting tidbit from this conversation. Let's see if I will use my my template again, and I will be able to actually produce something. No, I think maybe I broke something. Anyway, so the idea is to work once, like exactly once, right? You probably heard about this, the exactly one thing. So this is exactly how it works. It works exactly once. Now, let's go to some more complex use case. So we learned that Kafka with Kafka Connect can be like a little bit more than just a dump pipe, because pipe has some a little bit knowledge about how to bring data in and data out. Now, we also want to do some transformation of this data, right? And since we're talking about databases, we're probably talking about SQL. How many of you guys know SQL or think you know SQL? It's great, amazing, right? Because it's a kind of requirement for modern software engineer that you have 15 years of SQL experience and so far and so on. So we were thinking, yeah, so there are very big number of people who know Java, right? Arguably, Java developer know Java or some other language. I'm not gonna call it aloud. But there are so many people who know things like SQL, some of data stuff, or at least like wrote their select star from table thing once, so mean that we also know SQL. And we're thinking, okay, so how we can make things, all things stream processing much easier for people? How we can do that? So we developed this tool called KSQL, which is a SQL engine for Apache Kafka that allows you to focus on stream processing capabilities of your app using tools that you can easily pick up because it has a lot of concept with existing things. And KSQL provides the ways how you can, without, when I say coding, I mean actually compiling things, like compiling and deploying things. Because we still will be coding, and we can still call ourselves developers on SQL or KSQL language, because we will be writing code. But we're not going to be compiling this code. We're not going to be deploying this code. We will be just simply executing this one. So there's a ways how we can do this from UI, from KSQL CLI. We'll be using this most of the time. KSQL exposes API through the REST, so you can interact with KSQL with any existing language. If there is no Kafka stream processing library in your language, for example, there is no Kafka streams in .NET. However, your shop is building stuff in .NET. Maybe I don't know if it's appropriate the technology and the J. The conference starts with J, so this is why maybe some other language, non-JVM. And you still want to get all these benefits of stream processing, you can interact with this and submit a query through REST interface. And once you played around enough and you're happy with the things that you have done, like, hey, let me just try to explore something. I'll write some SQLs, play around, and after that, okay, looks like a good outcome. You bundle it up in a SQL file. You deploy KSQL with a simple SQL file, and you're done. You're not doing any like compilation things. You can version control this file because it's a text file, and you can also apply all things software development lifecycle in order to do your development things. The cool thing about KSQL, it allows you to interact with other technologies. If you're using some different stream processing technology, like maybe Spark streaming, maybe Flink, maybe something else, you still can use KSQL because Kafka happy to, for many readers, for many consumers, Kafka was designed to be heavy on reads. So this is why you can easily use this in conjunction with some other things, including Kafka Streams, which is an embedded library for Kafka. And the KSQL, you can scale this out, just simply bring in new instances. Kafka consumer protocol makes it easier to write application that would be easy to scale. And KSQL uses also features that were extended at KSQL in the Kafka Streams, where you have all capabilities of modern stream processing things, including windowing functions, including different the primitives for grouping, local store, so far and so on. A lot of things. And that just makes things simpler for you. So fault tolerant, backed by Kafka. Everything works smoothly. If one of the nodes goes down, data will be preserved in Kafka. So the KSQL is not running in Kafka. Your data in Kafka known as a proven technology for storing data. Kafka not losing messages, your application losing messages. If you want to talk about this, at me at Twitter. By the way, it's my Twitter downstairs, down below. The last thing about the architecture of the KSQL. So KSQL is standing on the shoulders of technologies that are already part of Apache Kafka. We have a producer and a consumer API, which is essentially Java API, if it's the lowest possible API that you want to interact with Kafka. It has methods like a subscribe to topic, you can send to topic, you can start transactions, so far and so on. When you want to go up, so for example, you suddenly not get paid for lines of code that you wrote, so you need to focus on actually being effective. So you need to move to Kafka Streams in this case, because when you're dealing with low-level APIs, you actually reading a lot of code. You're reinventing a lot of things. You can build your own stream processing framework on top of producer and consumer API, again, unless you get paid to do that. Otherwise, if you want to be efficient, the Kafka Streams provides a great set of abstractions that you can focus on dealing with your incoming data. For example, if you do simple transformations, simple filtering, so maybe you don't even need to use Kafka Streams, you can use KSQL for that. But if you're doing things like you just want to do things in Java for some reasons. Now, and finally, the KSQL itself, it hides all these things, and you're focusing only on DSLs like streams and SQL like DSL. You still can use Java if you want to extend capabilities of this engine. You want to do something, I don't know. We have my colleague that actually loves to do all things machine learning, deep learning things. He actually has a set of UDFs that he trains the model from KSQL. So he wrote the UDF, he extends syntax of KSQL that allow him to do simple things much simpler and complex things possible. And this is how you should, evaluate. It's one of the maybe most important slides when you're trying to figure out which way you should go, how you can start with stream processing. You can start from bottom up, or you can start from up and going down as soon as you need to have more flexibility on the things. Now, demo time. I have my SQL database that will have some information about customers, and we'll try to do something with it. So basically, it's ratings information. People go into to places and put some ratings. How many of you guys left any angry ratings? The awful place, never again. These people make my life miserable. So we're going to be tracking this, the people, not for the punishment. We will try to figure out what the hell is going on there, so we can improve our service. So in this case, we have our data coming from let's say website where all this information is. We have some database that has some extended information, so we will enrich our stream of ratings, and we will be using this dashboard to visualize things. All right, we're gonna be doing some SQL. We will try to get list of pool ratings first, and I will switch to slide later to explain you a couple concepts here. All right, so everything is looks like is up and running. So in order to do things here, I have a KSQL CLI that allows me to execute my KSQL request, and I have my SQL CLI that allows me to execute stuff around relational databases. So for example, I have show tables. I have tables about customers here. KSQL has some of the similar concept. I can do show topics. A lot of things here. So my demo kind of half worked. At least I have a topic created, right? And one message was produced. All right, enough of that. So I need to move on. And so the cool thing about the KSQL is actually can enable you with the higher level things that you don't need to even use the low level tools like a consumer producer from console. You can do it from KSQL. So for example, I want to see the topic content. Let's see. So I have this topic. I can do print from beginning, and it dumps all this information from this topic. So how does data end up on this topic? My connector that listens to the database did this initial load, and when I will change this data in my SQL, I will get this update thing here. So let me show you this. So I have a very popular, it was very popular in England. I think it's an English singer, Rick Astley, one of the favorite singers of Her Majesty. And we have him in our database as a customer, number 42. So I just inserted this into my SQL, and what happened here, my CDC connector detected this change and pushed data into Kafka, where my KSQL server listens to this. You see, there's no prompt here. There's no how we can say there's no prompt. There's no how we get it, greater than this thing. This is what I'm talking about, right? Because my SQL here sits there and waiting for my commands. So KSQL is actually executing continuous query. When I said print content of this topic, it will be running this in this session to the point where I'll click Control-C. So now it's stopped, right? Are we good so far? Any questions, any pressing matters? Okay, cool. So now, next thing is that let me do, so I did insert So I inserted this, how this Debezium will handle the updates. And I have some queries for updates. So I'm updating status of the customer with ID 1 and updating from status bronze, and after that updating to platinum. Let me actually continue to run this so you will see this actually is working. And when I will click the platinum, I'll get this update here, and it came for user ID. We see this is user ID, number 1, and we get this update. All right, so far so good, right? So far so good, and we're moving on. We mostly, let me hide these guys a little bit. Now, let's do something else. So first of all, so topics is it is an abstraction that that Kafka has, but to perform certain things, we need to build up certain abstractions on top of it. So this is why the abstraction of stream that essentially materialized from Kafka topic. So we need to build a stream, and who can tell me what this S stands for in SQL or KSQL? Structured, right? So we need to get some sort of structure. We need to bring some sense, because like our developers or like the person who's working with the KSQL stuff, he needs to know about data. Now, you can share the schema as a part of SQL, and in the SQL we know there's a data definition language and data manipulation language, when the data definition essentially defines your schema. We also can bring the schema. This is why I showed you this little fellow called schema registry. So, and I will show you how we can use this thing from schema registry that we called, we're creating a stream called ratings. And the way how it looked like, so this is how we're doing this. And as you can see here, we're not specifying anything here. We're not specifying, I'm not specifying here, not type of these things. I was just doing one simple thing here. Value format is Avro. Stream is created. So now let me do select. And we will see what kind of, first of all, let me do describe first. Describe the stream ratings. And voila, like automatically I have the schema. So the way how it works, so KSQL is smart enough to get information from the topics. And inside the topic, we have just the binaries. But this is not just simple binaries. This binary encoded with the Avro format. And there's one byte that is responsible for all these automagic things. It's called the schema ID. Based on schema ID, the KSQL able to communicate with schema registry and retrieve this schema from the schema registry in order to materialize this data format. So this is quite powerful once you standardize on the things that actually have a schema. Like you can deal with JSON, because KSQL also supports JSON, has rich capabilities for parsing JSON. But JSON is extremely terrible data format if you need to communicate this. Yeah, it's easy to read like for human, but if you have a couple megabytes of the JSON file, you want to read this, or you want to like optimize it to make sure that it arrives much faster. So you remove this self-described like repetitive fields and so far and so on, and use the binary format like Avro. So in this case, it also allows me to create this kind of awesome things. Where's my? So let me show you how we can do simple filtering. So I'm starting this the continuous query that will be constantly running with information from the stream of ratings. And what I'm interested in that what are those poor ratings? Like where is this the problematic information? You see, meh, never again. How many of you just posted this somewhere in Yelp or some other social media? Never again. I'm not going this place anymore. Come on, guys. We did this once. Everyone does. So, and also we have some additional information. We have some information about where this came from. We know how many stars this message received. You can, there's some repetitive things because obviously it's a data-generated thing. So it would be cool if the people will go and, rate this in real time, but it's very difficult to convince people to do anything during the live demo. So that's why, I need to have a data flowing. Now, so the cool thing, you can say, Viktor, okay, cool. So this continuous query is interesting stuff, but what's going to happen if I close the session of my KSQL CLI? What's going to happen with this query? Will it be interrupted? Yes, it will be interrupted. So this continuous query runs until data arrives or until you interrupt this. But we want to have this query to be a persistent. So you wanna run this in the background all of the time. So we do, we're creating stream, stream with the pool ratings. So how many of you guys did this in SQL? Create table from, or create view from, and after that you're providing the SQL. So the KSQL supports similar concept. Now, this stream that we just created is up and running, and we're constantly populating this with data. So that's why we will go here and print only 5 messages. As you can see here, I'm specifying this limit 5. This is where I am standing. Also, let's take a look into some of the scribe extended. So we're application developers. We want to see some other things except data. We want to see some data about our data, metadata, or metrics. So, and the KSQL also got you covered. So you can have, for the stream I just created, it's constantly running, you also have some metadata. In this particular case, we know how many messages were pushed into the stream since this stream was created. So if I will keep this running, I will see that my number of messages is increasing. I have information about throughput. I see how fast my Kafka pushes stuff into my KSQL. And I see when the last messages happen. All right? So I also can do the things like explain. It can print me a plan of this query. It's not going to be like a typical query plan like you probably seen in any like SQL tools, because it will be printing a Kafka streams the topology information. So because every query that we're executing with KSQL is backed by a small application that runs Kafka streams, because everything is written in Java. All right, so far so good, right? So we saw this, everything is working. Now, let's talk about state. So there is probably you learned, but I will repeat this, that there is a thing called stream where we have a history of events that happened all the time, and all these messages that we have in Kafka topic or in stream, if you want to have more high-level abstraction, these messages are represent whole history of things. So basically, you can replay those. Kafka provides persistency, so you don't losing these messages if you were absent where something was generated. Sorry. Now, but sometimes you really don't care. Like, if I would tell you story of my life from my birth, you don't really care. But you care is my current state, that I'm here presenting and talking about Kafka stream. So you care about state. In order to represent the state, we're actually using tables. Tables in your SQL database is representing current state of your data, because actual history of your data is represented in transactional log of your database. So actually, this concept was there like in the books, and if you were learning how to build your databases, you probably need to. You already know this, that the log is a essential data structure for building data structures. But let me give you an example that will allow you to better understand. Because when I'm talking about money, people pay attention. So let me talk about money. In this case, people will pay attention. So we have a stream of payments that go in through Kafka topics. So for example, we have this lady Alice that just deposited 50 euros. To represent the balance, the state of her account or state like balance sheet, our table would look like this. Like we have a key Alice and we have a value of 50 euros. We continue reading stream of payments, and stream of payments look like this. We have two events. We have a Bob, gentleman named Bob that just deposited 18 euros to our account. The way how our system looks like, we putting things in motion using the streams of events, and we're using table to represent current state. So this is important to understand that the table will always contain latest and greatest value for a particular key. So essentially, the table is a representation of the state. We use the same concept in KSQL. We use the same concept in Kafka streams. So basically, your source of truth is out there, but this out there is a log. So log is a data structure that will have all these messages. So your table is actually cache that was taken as a snapshot of this log. Very interesting paper. If you're into, paper we love type of thing. All right. So let's get back to demo now. Let's play around with things around our ratings, and we'll try to find this people, because we see only sources of these troubles, but we don't see actual people here. Like what's the name of the user? So now we're talking about things like this. So a couple of things here. So the Kafka, remember when I said like you can replay everything. So in the KSQL also supports this concept. So I can say, okay, go and reset my offset of current topics from the very beginning, and after that create stream. So what it will do, it resets offset from the very beginning of the topic. It creates the stream of the customers from the very beginning. So I'm starting from very beginning. And after that, I am starting two streams. One customer streams, another one stream of just like source information. So in this case, I'm using this technique that allows me to, the constantly reading for a particular person. In this, I'm just reading stream because it's much easier for me to operate. It's structured, and I have data that I will enrich in future. Now, in order to do enrichment, I will do joins. How many people love do joins in databases? Everyone does, because it's the most favorite question. I have two streams. Can I join this? Yes, you can. Yes, you can. And in order to join those, because distributed join is extremely slow and painful operation, we need to figure out the ways how we can localize two data. So we're joining by certain key. It is not relational data, so we're not joining by individual property or the column name, because we need to rekey. We need to change our stream in order that we will be able to join this with something else. So we will do this thing called that we call rekeying. So what it does, we're creating another stream, and this stream will be listening data from our source stream, and will generate this or place data in new topic based on certain key. Kafka has the concept of key in messages and value. Based on the key, you can figure out what partition and what topic will have this data, right? So in this case, I did this rekeying. So the way how I did this, I specify the key, and the case streams handle this automatically. Now, what I want to do next is to, we have this guy, we have the information here. Cool. So we have information about the customer. And because customer usually not changes very often, we use the table construct in order to store information about customer there. So this is why we will be joining stream of ratings with our customer information. So what we want to have a derived stream that will include information about customer and his ratings. Where is it? We did the rekey. So next one is, so we showed that, and we do. Now we're joining. So the way how the join works, we have two things here. So first of all, we're getting rating stream, and we have a customers table. We're joining streams and table. So right now, I'm doing this as a select, and I should be able to see information. Information of certain guys, some ratings and stuff on. So the data is constantly floating. Now let's create this stream. So in this case, we don't need to display this on the screen. We will have the stream constantly running that will constantly join our data, right? So this is a process of enrichment. And you see, like this is like quite a complex query here, but it allows to do very complex thing without like writing actual code to figure out what is there, what kind of stuff we have here. Right? So we have this. It works. So let me show you if I will do select from this one. So we see these customers that for user ID, so all this information came into play. So let me actually update something in database, so you'll see that we can do things like, so we're updating customer database. So the message will go through all the steps that we went before. It will be captured from the MySQL. It will go through the steps, and it should appear here in a moment, because we have this user ID. Let me see if it's actually user ID with number 2. Yeah, it's number 2. Let's see if we actually updated thing. Yeah, looks like it's went through to space and returned back here, and it's updated over here. So this is our Thomas Smith guy, I think. Hopefully, yeah, I think it is. Now I have my dashboard that backed by Kibana, and I should see these unhappy users here as well. It will be also populated through this Connect. So another thing, one last thing that I want you to show, probably not. I will skip that part, but you'll get the idea. So basically, I will go. This is what we're doing here. This is what we did. This is where the demo is placed. There's one cool thing is that you actually can do, or well, we still have 2 minutes. So we can skip advanced interrogation, and I will show you cool things. So okay, it's interesting thing that we did in order to get information about users. How we can notify our the customer success team. So in this case, we will be sending some of the notification to Slack. So I have this small app that actually does communication with Slack. What the hell? All right. So let me see. Export. Probably need to expire this after because what goes to internet, it's already in internet. And this small app called Python Notify. So let's see if I did everything correctly, and I will be able to get any updates for my application. So we'll wait while go to internet, to space. Okay, so unhappy customers are not there. Am I forgot to do something with this? Okay, let me see if maybe I forgot to create a actual stream. Streams of unhappy. Here we go. Now, so I should be able to see this dashboard very soon, and I should be able to see messages for unhappy customer. Here we go. We have some unhappy customers, and I'm starting getting some notifications. So I will show you that I'm actually receiving this stuff because it's a live demo, right? So what could possibly happen? So 2305. You see right now it's my phone, and if you ever been on call, you should start seeing something like this. So I'm getting notifications from my application, from my database, where the user go into my website and saying, "Hey, clean this toilet. This lounge is filthy." And I start getting this notification. So I'm a customer success representative, and I'm so happy that I have all this automation. So, at least something is working here. And also, like my boss, because he's a boss, he's in office, he can see this in the dashboard, all this. And now I'm starting getting this notification on my watch. So notifications are everywhere. So super, super, super cool. All right. So many unhappy customers. So the most important link here is the community. We have a Slack community with people who use the stream processing things. They're doing something with stream processing. We have engineers who are sitting there and working with the community. We have free books for you. So we're here to help you build the stream processing world and the event-driven world. So go grab those. One of the best books about Kafka is the Kafka Definitive Guide. Only one book that you ever need in order to understand Kafka. And if you're building event-driven microservices, Ben Stafford book about building event-driven system is must-have. All right, so you can tweet me at the JMUSSA. Thank you so much. Do not forget vote for this session. I will appreciate this. Hopefully, I show you something that you can build quite complex system in less than an hour. And thank you so much for your time. You were awesome. Thank you.